Our team, NPK4EVER, dealt with the challenge of manure management from large animal farming operations as a new resource for fertilizer and carbon offsets. Large animal protein manufacturing facilities create an excess of nitrogen, phosphorus, and potassium, which ends up overwhelming the local landscape where this animal protein is being produced.
The challenge in the past has been that there hasn't been available technology in order to recycle animal waste cost efficiently.
Today, most nitrogen fertilizer is produced at energy-intensive factories that consume 1% of global energy supply, or mined from limited phosphate reserves. The benefit of drying this material out is that it's a huge way to offset carbon both on these animal farms and in the fields where the new fertilizer could be applied. And that's what NPK4EVER is all about. Fertilizer going in a circle.
We worked with Danny Jones and Tasman Hussein's code, originally intended to examine ethanol sourcing and factory locations, and we modified it here so that it could accommodate the manure feedstocks as opposed to ethanol.
Where we actually used our data for the model. We defined a few characteristics here to make sure we had the right nutrient makeups, factors for how much it costs to travel, and such right here. Here is our target price for the end result, and that's per carbon ton, I believe.
Yes.
And then here is our actual model, and this is where the bulk of the code was within SAS.
We then identified potential depots where the manure from these confined animal feeding operations could be consolidated and dried before being shipped more cost effectively to fertilizer factories around the country. Our model showed us the price curve for carbon offsets that would stimulate a new fertilizer economy on small farms around the United States. At $105 per metric ton, we started to find solutions where a new circular fertilizer economy could work. Our model's outputs dictated which counties would be eligible to cost-effectively ship raw manure to depots for pre-processing and on to fertilizer factories for processing. On the x-axis is the price per metric ton of carbon, and on the y-axis is the total number of depots or factories that could be constructed at that carbon offset pricing level. The fertilizer, though, doesn't end its journey at the factory. Naturally, it could go on to be land applied in fields, an opportunity for further analysis on our part. A company, Anuvia, that currently uses such a biosolids-derived fertilizer product claims that it reduces greenhouse gases on each acre planted by 32%, in addition to the gains that we've already described by offsetting the raw emissions from the manure itself. We've taken steps to identify a solution for a problematic waste stream arising from animal protein manufacturing, and further work would reinforce and help further incorporate associated carbon impacts to better understand the cumulative results from using recycled manure in a circular economy that focuses on improved nutrition and reduced carbon emissions.